Oh, kill him!
Today we're going to talk about the physics in football hits. We are going to cover how impulse and momentum correlate with football hits. We are also going to talk about whether football hits are considered inelastic or elastic collisions.
Impulse is force times the change in time. Impulse is change in momentum. Impulse equals the final momentum minus the initial momentum. Momentum is equal to the object's mass times its velocity. Therefore, impulse is equal to the final mass times velocity, minus the initial mass times velocity. Doing some moving around, force equals the change in momentum over the change in time.
To increase the force, you could increase the mass, increase the velocity, or decrease the time of impact.
This is a hard knock. The master of disaster, 15 years, he's been lighting people up over the middle.
Ran a 2 and through. Whether it was his decision or not, guess what? It was a bad choice.
So here's a little example problem for you guys. Mr. Jadeveon Clowney has a mass of 116 kilograms. After the snap of the ball, he accelerates to a velocity of around 6.7 meters per second.
Wow. Michigan at the 41. What a hit! Ball's free on the ground. South Carolina deserves to have it, and they do.
The time of impact of the hit was 0.05 seconds. Together, we want to calculate the force generated by this hit at impact.
In this problem, we were given the mass of 116 kilograms, the velocity, which is 6.7 meters per second, and the time of impact, which is 0.05 seconds. We want to use this information to calculate the force. Since the initial velocity is 0, we can find the force by using the mass times the velocity divided by the change in time. After plugging in the numbers, the force generated was about 15,500 newtons. Did you know it only takes 4,000 newtons to break your femur? This hit generated 15,500 newtons.
Damn!
So now we're going to talk about inelastic and elastic collisions. Similarities between the two. Momentum is always conserved. Therefore, the initial momentum of the first object plus the initial momentum of the second object is equal to the final momentum of the first object plus the final momentum of the second object. Using this knowledge, we can use the mass of the first object and the velocity of the first object plus the mass of the second object times the velocity of the second object is equal to the final mass of the first object times the velocity of the first object plus the final mass of the second object times the velocity of the second object.
However, football deals with inelastic collisions.
Inelastic collisions involve a loss of kinetic energy, which is lost by another means, such as heat or another form of energy. An equation for inelastic collision would be the initial momentum of the first object plus the initial momentum of the second object, which equals the combined masses times the final velocity. So I got it.
So we get this down packed. Let's work on another example problem, guys. Let's get to working.
So we're going to revisit the first problem. We're going to spin it around a little bit. Mr. Connolly weighs 116 kilograms and is traveling at an initial velocity of 6.704 meters per second. Mr. Smith, on the other hand, only weighs 79 kilograms and is traveling with an initial velocity of 4.469 meters per second. So with this information, we want to find the final velocity of both players after the collision.
We are given Clowney's mass, which is 116 kilograms, and an initial velocity. Since he is moving to the left, we are going to make this a negative number. Smith has a mass of 79 kilograms. Since he is moving to the right, we are going to keep his velocity a positive number. With this information, we want to calculate the final velocity of both players. Since we discussed how football hits are inelastic collisions, we are going to use the formula we already stated. Doing some moving around, the final velocity is equal to the initial momentum of Clowney and the initial momentum of Smith divided by the total mass of the two. Plugging in the numbers, we find the final velocity is negative 2.16 meters per second.